Today I'm going to show you 5 ways to use LEDs to take your DIY projects to the next level. This first LED project is the easiest to retrofit into existing projects because it doesn't need any hard wiring. It just uses a 5-volt USB battery pack and some 5-volt LEDs, and everything is in line, so you can literally fit this setup into any project that you have. You just got to find some space for it. Now, I built 3 floating shelves for my office, and I wanted to have some nice accent lighting for having it in the background shots and just kind of highlighting the things that I put on them. So I've got a whole video documenting this build process, so I'm just going to show an overview here. If you want all the details, you can check out that full build after this video. But basically, they are hollow shelves made out of maple plywood. They're easy to install, and having that opening gives me plenty of room that I could add in the electronics. So this is the perfect kind of design for a battery-powered project. To make a recess for this little aluminum U-channel, I'm going to put together a quick jig. I used the offcuts from those very first cuts on the pieces of plywood, and I cut them down to 3 inches because I want the lighting 3 inches from the back of the strip. Now all I'm going to do is put this in between them. Now I can just CA glue on the end cap here. All right. That will work. I did a couple test cuts with the jig and I found the depth that I need, and this is going to fit in there nice and flush with the surface. So now I can cut the channels in the shelves. The grooves are in place for the aluminum channel, but now I need to make some holes in the channel as well as the bottom of the shelf for the LEDs. There's going to be little connectors that go in to hide all the electronics and still connect to the strips on the outside. I wanted this to be completely wireless so I could run it off of a USB battery pack and then have a remote control to control it. Some of them also have Bluetooth and apps and things like that, but those take a little bit more power typically. So this is a cheapo version I bought just to see how it looked versus this little more expensive varieties, but here's what they look like just to show you a little comparison. So these are both running off the battery packs. This is the cheaper version with the 80 lights per 5 meters, and this is supposed to be white. It is definitely blue tinge, so it's not a very nice light at all, and they're very spread out. Versus this one, which has 300 per 5 meters. Check this out. Now this one looks way better. It's got a lot more pixel density. The white actually looks white versus blue, and this is just a much better product. Both of these run off of remotes, and they have different types of modes that you can use. And whatever you buy, make sure you get RF radio frequency versus infrared because it doesn't need a direct line of sight to control it. Now the one downside, the one I'm specifically using, I already had the lights, so I just bought a controller, so it's kind of a bunch of different pieces you have to piece together, but I love playing around with electronics, so I have fun doing it. We've got a battery which has a USB powered adapter that goes into the controller, into the LED, and this works great. The problem though is because it's RF, it's always listening, meaning it's always draining the battery. So you can see the light is on even when it's off. But the switch is gonna be the secret that's gonna help the battery from draining when it's just not being used. So I'm gonna wire this into the power cable, but eventually I will need to recharge it. So I'm gonna use this extension cable so that I can charge the battery from outside of the shelf. I will just put this right into the bottom of the shelf and then connect the inner part into the battery. And that way I can plug in and charge the battery. I'm gonna get all this stuff wired up and then we'll be ready for install. All right, let's test this out. Yes! Oh, it works. All right, this is looking great. The button is working, and now I am ready to install these, but I grabbed the cleat just to take a little look. I did not factor this in at all, and this runs directly into the button and into where the power charger is going to be. So I'm going to have to cut this one down, but for the other two, I will adjust it and move the buttons closer to the front edge. You know, we almost got out of it, but mistakes were made. I'm going to wrap all these up and then install inside. All right, this fits great. Put the rest up, we'll be done. Let's see if they work. Oh yeah, that's nice. Now for this next project, I leveled up my floating shelves, including that task lighting that we're looking for, and also still keeping in the accent lighting, but this time it is a solid wood shelf versus hollow. So lots of things to learn here. Now again, I've got all the details on this build in a full video, but basically I milled down some solid maple and glued it together into a big maple blank that I could use for this nice beefy shelf. Now there are a ton of different LEDs out there because LED lights are like crack for teenagers and YouTubers, because what good is a project without some LEDs? So here's the three types of LEDs, and these back two right here, these are actually RGB, will do all colors, and this first one is a special LED that only does white, but you can see on the back, you can just see how tiny these little strips are and how far apart they are. So these are about 2 inches apart, these are about 3/4 inch apart. I would definitely not recommend these back here, and this is what these look like. So even though they are RGB, when you go to the white, it's got a very blue tint to it, so they just don't look nice. Now this one in the middle, this is the one I've used on a lot of projects before. You can see the difference between the whiteness of these strips. This is a much nicer white. Also, it does do red, green, and the blue, but it can also do other cool things like this and have all kinds of cool little animations that will go across there. And these are individually addressable LEDs, meaning that each one can be a different color. Now these last ones here are special. These are called FCOB LEDs, and it stands for Flexible Chip on Board. And basically what that means is it has a diffuser here, and there are a lot of little itty bitty LEDs, but they are very strong together. And if I go up to full brightness, these are really bright. So I'm going to use the FCOB lights and just put some light on all the stuff that I'm going to be working on. And for the RGBs, they'll be shining up so I can have a little cool light on whatever I'm displaying up there. Now the plywood shelves that I made had this nice cavity in between them for the mounting, and that allowed me to just put the electronics wherever I wanted. Obviously with a solid piece of wood, we do not have that cavity. So I need to make it. So before I start cutting into this back, I need to know how it's going to be attached to the wall. So I went into the office and I measured where the studs were, and then I transferred those locations onto the back here. So I'll know where those stud locations are, and then in between those is where I can make the little dig out for the electronics. So it looks like I'll have a nice little section right here at the end, and this is where I can put all of the electronics. To drill out this little area, I'm going to use a little auger bit, just like I used to drill the holes in my bench top. And I'm not real confident that I can cut straight holes, so I made a little jig for this little guy. I'm pretty proud of it, actually. I just kind of glued 2 pieces to this little scrap board right here, and then mounted this in the center, so I know that the holes will be right in the center. And then also it's going to kind of help me steady it, because it would be hard to balance this plate right onto here. All right, so let's hog some of this out and see how it works. Note to self, do not push this down when this little pole is right under the trigger, or you'll shriek like an elementary school kid. I'm not sure if this is my best idea or worst idea, but kind of feeling like it's my worst. Ooh, that looks pretty darn nice. All right, I got that done, and do not worry, I have retained my title as world's second worst chiseler. Yeah. Anyway, I need to figure out where I'm going to put the LEDs so I can start running the next holes. I am a little bit concerned about how much I need to recess them on the shelf, because they're going to be here on the front, because I just don't want them just like shooting into my eyes like a million suns. So to test that out, I'm actually going to use this 2x12 that I was talking about. So instead of just cutting recesses in there, I'm going to get a little bit smarter and instead just put little strips on the outside to represent a recess. I've got the shelf mocked up, and in the center here, I just have one little 1/4 inch strip. Then I added a little 1/8 inch strip on it to get to 3/8, and then 2 1/4 inch strips for a half over there. Don't ask me why I did them out of order. And then I'm gonna put this up on the wall and then just see how each of them looks. All right, let's try 2 lights. So after looking at the mock-up, I think 3/8 of an inch is gonna be just right. And it's because my wife agreed on it, and whatever she says is always right.
This one looks good.
Okay. Take that to heart, guys. Now all I gotta do is use my handheld router to route out the groove for 2 LED strips. That worked out fairly well. Now I have this little channel for the LED strips in the front. What I have to do now is get the wiring into this cavity. So the cavity is right here on the backside, and I need to go through, but this cavity is only like 4 inches deep. So I'm going to get a smaller bit and drill down all the way into right underneath here, and then I'll drill another hole right here to connect those two. And sounds easy. Let's see if it works. I'm gonna step it down and use this little smaller guy. The problem is that it's not quite long enough, but I do have this big extension. And so I think I'm gonna start this with the jig so I can get it straight, then I'll pull it off and plug this in and go the rest of the way. All right, what's going on here? Oh, the spring. The spring is bottoming out. Ah, jeez. I'll do this by hand. I'm thinking of starting a new band, but it's going to be called Idiots with Drills. So yeah, if you're interested in joining, you think you have the qualifications, just let me know down in the comments. We're open to everybody. All right, here we go. Oh, gosh. That is just a hideous sound. That's the first single off of our LP. All right. With any luck, there should be a hole right underneath here. Hey, all right. That worked. On the back side of the shelf, I'm going to also be doing a groove, and that'll be for the RGB lights. And it's going to be pretty much exactly what I just did, so we're just going to blitz through it. I got the channel routed out, and I did one deeper pass in the middle and then a wider one on the top. I have the LEDs down in the bottom channel and then the plexi on top, so it'll be nice and flush. Now I just got to connect it down into the base. This will be much, much easier than the other side. There we go. Now all this is ready for wiring. So now what I'm going to do is just start installing the LEDs. So I modeled and 3D printed some of these little strips here, and these are for 10mm LEDs, and then I can just super glue them into the channel, and then the LEDs are going to snap right in. Now my other floating shelves I ran off battery, and although that was a cool idea and nice and novel, it was a pain in the butt to have to recharge the battery all the time. So I'm gonna be running power through the wall, and I'm gonna use some in-wall cable, and then I'll have this little jobby here that the cable can come out. It'll be hidden behind the 3D printer, and then I can plug the things into a power strip. All right, with a hope and a prayer, this should go up and I can get everything plugged in. I did run 2 lines here, a 12 volt and a 5 volt line. So each of these will have their own dedicated power, and I can always change out the chargers and not have to mess with anything up there because this cable is just a patch cable that runs from the bottom up to the top. All right. Oh, that's sturdy too. All right, I pulled the 3D printers in here and put a few things on the shelf. Now let's check out the lights. First of all, the task lighting. This is exactly what I was hoping for. Tons of light here. But let's check out the RGBs up top. This is great. It's just a nice little ambiance up there, but I am super happy with how this turned out. It looks amazing, and the office is really coming together. Now the next project is a party coffee table that I built for Sam Adams and Timberland Pro, and it brings together two staples of a party: music and LEDs. Now, I built this whole thing out of cedar, which is definitely my favorite outdoor wood, and it's pretty easy to work with. Although it's not necessarily the cheapest, it looks amazing. Now, I wanted to make something really cool with kind of a Star Wars vibe to it. So after I got done gluing up that table, and I used the CNC to cut out all of those little holes and crevices that I'm gonna later backfill with some epoxy so that I can start incorporating the LEDs. And obviously, if you don't have a CNC, that is totally fine. You can use a router for these designs or any number of other ways that you could cut through that wood and get any design that you really want. The CNC work turned out great, and this design is going to be really cool when we backfill it in. Just had to do a little bit of cleanup on it. But instead of just picking one color of epoxy, I'm going to pick all the colors. We're going to put white epoxy in here, and then I'm actually going to route it out from underneath and then put LEDs in there so we can change it to whatever color we want. That's going to be pretty complicated, but we'll figure it out as we go along. But we'll start with mixing up some epoxy. I'm going to mix some slow setting epoxy. I'm going to use some Total Boat High Performance with some white powdered pigment, and that's going to give us a really nice look. And I prepped the table by putting a light coat of polyurethane around the edges so that the epoxy won't bleed out into the fibers. I also put a little bit of blue tape here so that it won't spill out the ends into the drink well. I'm just going to mix this in a few small batches and fill these up to the top and then let them dry overnight. The epoxy is all cured, and I ran it through my drum sander to flatten everything out. Way easier than doing it by hand. And I think I'm just gonna call this the $10,000 table, because I'm throwing about every machine in the shop at it. Now, if you're wondering how I'm gonna get the LEDs to light up from the back, here's how I'm gonna do it. So I made a little test piece, and I routed out some pieces in the back, and I found out the thing that worked best is to have a 3/4 inch strip on the back that I'll just route all the way through from the backside until I get to the epoxy. Then I could put this little bad boy to use, which is a wireless LED controller, and I'll talk more about that later. But if I light it up from behind, then we get this. So now I'm gonna route out those channels on the back side of the top, and then I'm gonna CNC a couple more holes in the top for something that's a little secret I'll show you later. After all the CNCing, this thing is looking like Swiss cheese. It also kind of looks like a cassette tape, if you know what that is. But honestly, I'm kind of second guessing myself. I should have maybe poured the epoxy a little bit deeper so I didn't have to route down so far, because I've removed a lot of material, and especially over here, you can see how thin it is. It really flexes on me. The next step is actually cutting the waterfall edges and folding up a miter and gluing everything. So I'm going to clean up those miters and apply some finish to this, but I'm also going to start working on the LEDs. So I've got the LEDs, and now I'm going to be able to lay these into the channels. And the way that I'm thinking about mounting them is using these little 3D printed strips that I have modeled up. So I've been kind of messing around with this. These, I think, will press fit in there. It'll hold the LED strip and then hold it tight, and I won't have to put any extra fasteners on here. That's the goal. But once I can lay out all the LED strips, then I can also put the electronics in, wire everything up, and it's gonna run off of two 18-volt batteries, which is gonna be great because I've got a bunch of those for my power tools. It's time to start wiring everything up, and I'm going to show you the entire kit that's going into the table. Basically, we have two sides. We've got the music side. Yes, these are 5¼ speakers, and that's what's going in those holes. You probably already figured that out. And it has a little amplifier, and I'm going to hook it up to this little converter that I have for my batteries. I'm going to bunch of these extra batteries, and then we can plug it in and use the 20 volts. Now, this amplifier can go up to 24 volts, so I don't have to do anything with the voltage on this one. Now, the left side, this is going to be where all the LEDs live. This will also be run off a battery, but these guys run off of 5 volts. So I need to step it down, and I'm going to use a little DC buck converter to take it from 20 volts down to 5 volts. And then I'm going to take it into this little guy. It's an ESP8266. It's a WeMOS D1 Mini. I'll have links below in the description to all this stuff in case you want to explore it more. And then that's going to run and drive the LEDs. The cool thing is the WeMOS is also Wi-Fi enabled, so I can control everything on my app. And I'm going to have this little red button here just in case we want to change LED settings. We should be able to push that and cycle through once it's in the table. And then I'm also going to put a little power switch so that we can turn this on and off. And all that's going to go into the front of the table, and I'm going to have a little control panel on the front with a power button for the Mini, the little controller button, and then the volume control for the amplifier. So let's get it all hooked up. Now, I prefer soldering all my joints and connections like I mentioned before because it's a way better connection. And when you have a ton of joints like in this project, you really don't want to risk signal loss like you can get with those push connectors. Now, you'll also see me connecting some of the strips with jumper wires, so you don't have to just have strips right next to each other. You can actually extend them and hide the wires in channels like I did here, and it has a nice segmented look that way. So you just need some wiring that allows you to run that distance, and then you can solder them together and basically put them into any shape and style you want. All right, I've got the speakers hooked up and we're going to try them out. I'm going to put the battery in here, which is hooked up to the amplifier, and the battery just mounts right underneath. Love that. And I'm going to go ahead and turn this on. All right, we are now in Bluetooth. Let me pull in a copyright-free song. Those sound really good. All right, the sound is working. Now it's time to check out the LEDs. Let me turn this on. Yep. Whoa. Oh, there they are. Let's turn all these lights out. Ooh. Oh, check that out. I'm here. You just can't see me. Check out the lights. Oh man, this is really cool, but it's going to be even cooler if I can control them. All right, unfortunately, I could not get it to work for me to control it with my phone. I tell you what, I'm going to figure this thing out and we'll have a reveal, hopefully with the LEDs working and maybe even some music. I'm going to fire this bad boy up. I'm going to turn on the speakers first and the LED lights and let those connect to the Wi-Fi. And I even got it working with the music. Now, the app that I used to control the table was WLED, and it connects with that little WeMOS Mini microcontroller, and I used a little microphone module add-on, and that's what allows the lights to react to the music. Now, that app is very powerful, even though it is still pretty automated. You don't have to do any coding, but I just scratched the surface. So I'm gonna leave a link down below to a video that goes over WLED and really allow you to dig in and see everything it has to offer. So the first project that I dove into with the microcontrollers was coding up a LED status notification to know when my kids' tablets were done charging. And I really wish I had had ChatGPT because the coding wasn't perfect, but still, it was an awesome project.
I'll be using the CNC to route the charging locations and some initials for my kids so that each of them will have their own designated spot and their own USB cord for the charging station. Now, these grooves will be cut all the way through the walnut, and I'm going to fill them with epoxy and then backlight them with LEDs. And this is the perfect application to use CNC, as doing this cleanly by hand would be nearly impossible for me. I'm going to have LEDs running under the grooves in the top, and I wanted to fill them with epoxy to diffuse the light. But instead of embedding the LEDs in the epoxy, I wanted to make sure I could keep the electronics accessible, so I only filled half of the groove with epoxy, and I left room for the LEDs to be placed down in there. I taped off the front of the grooves, and then I flipped the top over and I leveled it out for an even pour. Then I mixed up 3 cups of high-performance epoxy with a slow hardener. White pigment added to the mix is going to give the epoxy a nice look while it isn't backlit, and then diffuse all that light really nicely when the LEDs are going around. Now, each cup had just enough in it to fill one channel to the halfway point. So I poured them all in and I let the epoxy cure for about 6 hours. After that, I flipped the top over and I uncovered the initials. Now, the initials won't be backlit, but I wanted to put some fun colors in there with them for the kids. I mixed up some more epoxy this time using a fast hardener, and I added orange, blue, and purple pigments to the mix. I overfilled each letter and then I let everything cure overnight so I could come back the next day and work on it. When I got back, I peeled off the tape and I realized I probably should have used something more like a Tyvek tape or packing tape versus this painter's tape. I think it would have come off a lot cleaner. The painter's tape left this little sticky residue, but I went ahead and hit the epoxy with a card scraper to remove that before sanding so I wouldn't gunk up the sandpaper. And while I was at it, I went ahead and knocked down the epoxy letters a bit too, just to keep a little wear off of the sandpaper as well. But I probably didn't need to do that because my drum sander ate through the epoxy like my kids polish off that last Oreo before I can jump in there and get it. They always get me on that. I did some relief chiseling under the monograms. This is going to let the LEDs sit flush in the groove, and it makes a little place for the wires to go and not be interfered with. Of course, I wanted to go to the next level, and here's where I got a little bit out of my league. I saw a video several years ago by a YouTuber called Makjosher. I'm going to link below to his video where he made a light bulb turn on or off when his phone was done charging. I wanted to do the same type thing except use the LEDs and have some animation with it. My issue was I had no idea what I was doing because I've never done Arduino coding, and this is going to be the first time working with electronics in this nature. So I'm going to go super high level here, so don't freak out if you're not into electronics. The idea here though was to use this little microcontroller, it's called the Arduino Uno, and put some code on it so I could control the set of LEDs. So I glued the LEDs in place in the epoxy channels, and then I started wiring. I used a 6-port USB block to power everything. Next, I wired in these little current and voltage sensors. These were the things that I saw Makjosher use in his project, and it really makes the whole thing work. And this is going to let the Arduino read the current flowing through the cable, so basically it's just going to know if the tablet is actively charging or not. Now, my original plan was to just use one of these Arduino Unos, and I figured out how to measure all the currents at once, but what I couldn't figure out was how to control the multiple LEDs all at the same time, because it's basically a looping program, and so it had to kind of pause before it gave the instructions to each one. So an easier way to do it is I dedicated a single Arduino to each of the tablet charging areas. Now, this is obviously a more expensive way to do it, and a smarter person than me can probably figure that out. I wired everything in place and I secured the boards down with some screws and standoffs that I cut from little plastic straws. Then I installed the back, which is going to be a 1/2 inch shorter than the front. This left a little space at the top of the back so I could run the cables out to the top, as well as it's going to let out any heat that comes from the charging cables as well as the LEDs. I stuck the power block to the back with Velcro and I ran the charging cables out. I also did a couple cable clips on the cords so that they won't pull out the wiring if they get yanked on. Let me rephrase that, when they get yanked on by my kids. Now, programming these LEDs was a whole other adventure. I am not going to go into the details because honestly, I just did not figure it out. I tried to edit the code from Makjosher and make it work for my situation. I did get the LEDs to be off while it was not plugged in, pulse when it was plugged in, and glow a solid green when it was fully charged. Sometimes. Other times, it would just go blank after charging, or it would blink wildly when a tablet was not plugged in. So I definitely failed figuring out the coding on my own, but I'm just going to consider this a prototype as far as the coding goes, and as soon as I can figure out how to make that work and get some help from somebody smarter than me, then all I have to do is update the new code and we'll be in business. And most importantly, my kids think it's really cool that they have their own LED charging station for each of their tablets.
So after getting a little bit of experience with microcontrollers and coding, after that one, I wanted to really dive into the next level, which is obviously, how can I torment my kids using LEDs? Now for this one, I went the whole 9 yards. I used a microcontroller, I had LEDs with status notifications, a countdown timer, some buttons, a lock, and even some fun little sounds to go along with it. So if you're looking into diving deeper in electronics and LED, I hope this project gives you some good inspiration. Oh, the joys of working with nasty old barnwood. After I made that cut, here's what I found. That is a bark inclusion, and that would be right at the very top and probably the most conspicuous part of the entire project. So I think we need some help. Norm, what do I do, man? If you could send some of your practical wisdom through this picture into my workshop, I would appreciate it. Tell me what I should do. Help me, Norm.
Brad just cut a new one.
Thank you. Here is the base of the whole locking system that I'm starting with, and basically my whole goal is to turn on and off this little solenoid, and you can do that really easy, or you can make it really hard and have other things happen too. But right now, I'm gonna be driving that off of a little Arduino Nano, and that is a small microcontroller, which is basically just a little tiny computer that runs code. It looks for inputs and then does outputs. So it says, you do this, I'll do that. So I just put a little bit of code on here now to say that when I push this button, send the electrical signal to this relay, which will then power up the solenoid. So if I push the button, it opens for 1 second. That's just fun to do. So you could leave it at that and just have one button and be able to push it and have it open. But because we want to add in a lot more things and have a timer and also have some LEDs and have it do all kinds of fun stuff, we need to have the microcontroller. What? You've never seen a man polish his brass tubes before? I want to show you guys what I've been doing with the electronics. It has gotten a little out of control here. Now the whole idea of the cell phone jail is we're gonna have a timer, so I've added in a little LCD here and then buttons and little knobs here to make everything work. And I am not a coder. I did not figure this out on my own. A big thank you to Lucien Blancavort. He's got a project called the Time Delay Lockbox, and it was on Instructables, and I found it there and I used his code as the basis for the timer and to make everything work. I had to change around a lot of stuff. Now I'm just moving around wires trying to get stuff to work, and I have put in at least 40 hours worth of work into the coding and the arrangement and everything. But now I've got to take this big jumbled pile of wires and make it look nice. So I'm gonna put the LCD and all the buttons up here on the control panel, get that all in and figure out how to get everything wired inside there. Plus, I'm gonna add a few more bells and whistles to really make this thing awesome. All right, the finish on this turned out absolutely amazing. It is looking great. I got the door reinstalled. I also cut a little panel in here, and this is going to go right in front here. And then the phone charger will be sitting here, and then all the electronics are gonna be in the back. But now I've got this big jumbled mess of wires, so I can start filling everything in the control panel, and then I'll show you all the little goodies that I added to it. Now the challenge is going to be rewiring this because these are all really short wires and I'm going to need some longer wires. I'm still going to keep this on breadboard, which is fairly temporary, and I'm going to convert it to a smaller one though, because a lot of these things that are in the board down here are going to be going up into the console, so it should shrink everything. But I've only done this 1 or 2 times before, so I'm just going to get going and we'll see what happens. This turned out so awesome. I absolutely love how this looks. It's like a retro feel to it. Everything's ready to be transferred over, and I'll just hook it up. We'll take it for a run. All right, I've got it all set up here. Now we're gonna bring down my son, Cole. He's gonna see it for the first time. Turn around right here. Check out my latest project.
What? Is this like a prison for your cell phone?
That
Why?
is exactly what it is. So here's how it works. While the light's green, you can just open it.
Wait, that's actually so cool. Hold on.
So try to open it when it's locked.
All right.
Whoa, 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 dude.
I gotta try to open it.
Please do not do that. Try to open it like a normal person. Okay. If we want to put it overnight, we'll hit the set. We can put that to how many ever hours we need. And then arm. It's the Mario Kart intro, dude.
Oh! Wait, but why?
Why
Like,
what?
you could have just like checked my search history or something. Instead, you made this.
That's right. So now you can't open it. But I don't know. Try to open it anyway.
No. What is wrong
we
with
noped
you?
him. Once we get under a minute, now it goes into seconds, and it will count down for the seconds. All right, here we go. Get the final opening.
Okay, is it gonna say something to... Seriously? Mario!
Mario, what up? And now it is openable again.
I mean, on one hand, it's cool, but my question stays. Why?
If you want to check out the full videos of any of these projects, I got them queued up for you right there with all the details. I'm Brad. Until next time, get out there and build something awesome.